Today you are going to follow along with me for lesson 4. We are going to be writing products as sums and sums as products. So on your packet, please make sure you put your name and the date. And we are going to start with example 1. We won't ignore this slide. So example 1, you're going to have a table that looks just like this. What I would like you to do in this table is to use the distributed property to write the products as sums. So pause the video, take a minute, and I think I'm going to do exercise A with you. So if I were to distribute or hand out the 2, to everything inside the parentheses, I would ask myself, 2 times x would give me 2x. And then I would hand out the 2 to the 5. And when I'm handing out, I'm always multiplying, and it's a positive 5. So 2 times positive 5 is positive 10. So I just multiplied, and when we multiply, we get products, but we're writing the products as sums. So as sums, that means an answer to an addition problem. So I'd like you to go ahead and do letter B, letter C, and letter D. Once you are finished with that, please raise your hand, check in with me, and then you can move on to the next activity. Ignore this slide. And now we're going to work backwards for E through H. So now you see that you have the sums. So instead of writing the sum form, you are going to work backwards and write the product form. So I have to ask myself, with these 2 terms, is there a common factor between 5 and 30? And I want to try to find the greatest common factor, because there could be more than one, and in this case there's not. But I know right off the bat that 5 and 30 both have the number 5 in common. So, Smartboard does not want to work for me right now, so give me a second. Let's see if I do this for the work. Let's test it. Smile face. There we go. So 5 and 30. I know that 5 and 30 both have the number 5 in common. So I'm going to pull out that 5 and write it right here. And then I'm going to put a parenthesis. So 5 times what will give me 5x? Well, I know that 5 times 1 will give me 5, but I don't need to write that 1. I can just leave it as x, because I know that there's only one x there. Now, I look at number 30, and it's a positive 30. A positive 30. So 5 times what will give me positive 30? That would be a positive 6. And that's that. If I wanted to go back and check my work, I know that 5 times x will give me 5x. And then I know that 5 times 6 gives me 30, so I am correct. I'd like you to go and try letters F through H on your own, and once you are finished, please check in with me. And I would like you, I forgot to have you do this for the last one, so I'm actually going to work backwards here. I'm going to go back, back. Here, I would like you, for notes, I would like you to label this section right here as sums of products. If you need to pause the video so you can write that, go ahead and do it. I'm going to keep on moving on. And then I would like you to label the other part of that table products as sums. Products of sums. I know it's going to be tricky to go back and forth with remembering that. But just think, you're trying to go back to products here, and the other one, you're trying to work for sums. We are going to go to, I'm going to skip ahead to example 2. You are going to be answering the questions in your packet, but I'm only helping you with a few. The rest you should be able to do on your own. So, example 2 should look like this. I'll give you a second to find this. So this is just another tool in the math toolkit you can use, and this is called a rectangular array because it's in the shape of a rectangle, and it's showing you what each area represents. You have this area, which is 8. This area is 12 groups of y. I don't know what y is, but I just know that it's 12 groups of y. And this area is 2 groups of x's. So I need to work backwards. I know that the formula for an area of a rectangle is length times width. So I need to know something times something will give me 2x. What is that something? And that something that you use here will also need to give you 12y somehow and 8 somehow. So what common factor does 2, 12, and 8 have in common? I hope you were thinking too, because that is correct. So if I pull the 2, I'm going to put it right here, okay? So I know length times width. 2 times what will give me 2x? Just an x. 2 times what will give me 12y? We'll look at the numbers first. 2 times what will give me 12? That's 6. 2 times what will give me y? Just y. And then 2 times what will give me 8? And that would be 4. Okay? Length times width. Length, well actually this is width. Width, so length times width. Length times width. Length times width. So we need to write the final answer as sums. We're writing the sums of these products. So I have 2. Actually, I made a mistake. They were writing the distributive property. I have 2 because you have to multiply. So 2 times x, and then I'm adding this area, and then I'm adding this area. Before you were using distributive property with just 2 terms, but now we're extending it with 3 total terms. And the rectangular array is one of my favorite tools to use to show this method. So you will complete exercise 2. And when it asks you to factor, that means you're doing this. You're finding what number, well, 2, 12, and 8. What number fits into 2, 12, and 8? Common factor. So if you have any questions, just let me know. But I'd like you, actually, you know, I'm going to have you go ahead and do exercise 2. You can pause the video. And then when you're ready, I'm going to talk about exercise 3. So go ahead, pause the video, finish exercise 2, check in with me, and then you will watch the rest of this video. All right, so this is example, well, on my sheet it says example 3, but on your sheet it says exercise 3. I am going to demonstrate 3A, D, and I, and then I'm going to have you do the rest. So I need to go to D. Oh, there's D. For each expression, write each sum as a product of two factors. So here you have sum. Let's use a different color. Let's try pink. So here, this is sums. So I need to go backwards, and I'm going to figure out, I'm going to use the distributive property. So what do you see is in common with x times 3 plus 5 times 3? Well, I see a 3 and a 3 here. So I'm going to pull that 3 out. And I'm going to look at my first term here. Well, if I pulled that 3 out, that leaves me with x. And then I have a plus sign. And then I pulled the 3 out, so that leaves me with 5. Okay? Now let's see if that works, because I'm not quite sure. If I were to go back here and simplify this in standard form, x times 3 is just 3x. Plus, well, 5 times 3 is 15. Okay, so that's the standard form of that. Let's see if that works. 3 times x is 3x. 3 times 5 is 15. So it does check out. Right, I said I would do D, and now I'm going to do, oh, I skipped A, so I'm going to go back to A. Here's A. So same deal, but no variables this time. So I'm looking to see what number is in common here. It looks like, again, I have the number 3. So I'm going to pull the 3 out. Well, what do I need to do for this first term? I need a 2. Plus, if I pulled the 3 out, that leaves me with 5. I can check my work. Hand the 3 out to the 2, and that's 6. Hand the 3 out to the 5, and that's 15. And look what you have here. 2 times 3 is 6. 5 times 3 is 15. It checks out. One more. I said I'd do I, and I is a little tricky here, so let's see if I can do this. Let's look here. If I look at each term, I'm trying to figure out what's in common here. I always look at my numbers first. There's a 2 here, there's no number there, there's a 2 there. So I can't use the number 2 at all. So now I'm going to look at my variables. I have x, and no x here. And I have a y and a y here. What could I do? Well, you know what? I think I'm going to pull out my x's. I'm going to see if this works. I'm going to problem solve, and then we can check our work. So if I pull the x out, I'm going to pull it out. What do I need to get 2x? Well, I need a 2 here. And then in this, oh, you know what I could have done to make my life a little easier? I'm going to erase this. And some of you might have already jumped ahead and did this. I'm actually going to simplify this expression because I see some terms that I could combine. Because with addition, does it matter? Any order, any grouping? It doesn't. So really, this says, oops, I gotta get the eraser. I have 2x plus y plus x plus 2y. Any order, any grouping. With addition, I could move these around and I'd still have the same answer. So I'm going to go ahead and add my like terms. 2x plus another x would be 3x. Y plus another 2y would be a 3y. This is going to make my life a lot easier because now I can instantly see that I have a 3 in common. So I'm going to pull that out. If I pull out the 3, that leaves me with an x. And if I pull out the 3 here, that leaves me with a y. Easy peasy, lemon squeezy. So that is all we're doing today. I do want you to go back in your job. You're not doing example 3 with the word problem. I need you to make sure that you finish exercise 3. And if you turn the other page from the beginning of the packet here, from the beginning, everything should be completed and you should be checking in with me. So that means from example 1, exercise 1, and then exercise 3. If you don't understand what I described in the video, please raise your hand and I can help you. Thanks.